Now, previously we talked about water hardness, right? And I show you that when you mix calcium and magnesium together, calcium and magnesium salt together, they will create precipitation, which is a solid compound as their chemical reaction, right? So today we're going to look again on the hardness. So basically there are some a chart or a table to quantify what is hardness. Okay, so this table is for the Europe and North America. So as you can see, when they compare water hardness, for example, the first column over there, right? Sorry, my green screen limit is up to here, but you can see the far left, hardness unit per liter water. So they will have all these parameters to measure water, and the rest you can see from the chart here. Okay, I'll show you the Malaysia one later. Then so this is a table that I show you. So for US, when they define soft water, it means that when they measure calcium carbonate, CaCO3, less than 60 ppm. Less than 60 ppm, what does it mean? Let's go back to the table. Calcium carbonate, this one. Okay, so calcium carbonate, 1 milligram of calcium carbonate, you have 50 MAV, and this is 1 ppm. Okay, 1 ppm. 1 ppm means 1 part per million. 1 part per million. This one. 1 part per million means if you drop a drop of water, and in the instrument, it will scan for 1 million of particles, and if it can detect less than 60 calcium carbonate particles inside the water, it falls under soft water. Okay, and then the rest you can refer to this all these value lah. So less than 60, it becomes soft water. More than 180 ppm, if you refer to calcium carbonate, so it will be very, very hard. Okay, so this is if you talk about hard water, soft water, there is a standard to refer. There is a chart for refer. Okay, usually you can refer to the Department of Environment for the data, for the guidelines, or for the table. They will tell you what are the standard, what the value used to quantify soft water until hard water. Okay. Each country have their own standard. So you can see this one. Okay, so you can see this one is another chart. Okay, and this one is for Malaysia. It's have a long list. So if you want to see the whole chart, right? If you still want to see the whole chart, you can go and Google and go to the Department of Water Quality, right? Or you can look for Malaysia Water Quality Standard. Then it will give you a list of standard. So this is one of it for Malaysia. Okay. So what is important is that you've seen Malaysia standard before. This is only like quarter page of the standards. We have a long list there. So for Malaysia, right? For Malaysia, parameter on the left, you have lots of content there, pH, content, and so on. Then the unit they use to measure, and based on the parameter they have, they will group the water not based on soft or hard, but they will in Malaysia, we group our water into classes. For Malaysia, we use class and not like the US, they use soft or very hard water. But for Malaysia, we use class from class 1 until class 5. So if you refer to this table, if let's say I pick the pH, so I'm not sure whether you can see, but for the pH row, you see that if the pH level in the water they measure is between 6.5 to 8.5, it fall under class 1 water. Then if the pH level is outside the range, 6 to 9, then it fall under 2A, and so on. So they will have all these parameter. Okay, they have all this one, and when they measure water, they not only look at one parameter, they will compare, for example, pH and others parameter to match the category of the class. Okay, so they not only refer to one individual parameter. So for example, you see this class 2A and class 2A and class 2B, they have the same pH level, but how to differentiate 1A and 2A and 2B, they need to refer to other parameter also. Okay, so if they meet other parameter, then they fall under that particular category, and the rest you can read from the slides here. Okay. Let me show you a video about how to test the water hardness.
Are you looking for a simple way to test your water for hardness? Well, I'm going to show you 3 ways right now. Hi, I'm Gary the Water Guy. I own Water eStore and Water Store in Midland, and I simplify water filtration. The easiest way to test your water at home for hardness is using soap. Now, not detergent, this is soap. This is Castile Pure Soap, and that's what you would use. So what I've done, I've got 2 jars here. This one has 14 ounces of soft water in it. This one has 14 ounces of hard water, and I've added 20 drops of this Castile soap. And then what we're going to do is we're going to shake them up and see what happens. All right, so you can already see what's happened here. The hard water is turned quite milky, and there's virtually no suds whatsoever from this. But the soft water, you can see there's lots of suds, and the water underneath is quite clear. And that'll tell you this water's soft, this one's hard. So the second way of testing is you can use a Hume Water Care Hardness Test Kit. Comes with 5 of these strips. I'll put a link in the description down below and in the cards up above. So basically how these things work is you just dip it into the water, hold it in there for 3 seconds, and then you do a color comparison. They ask you to compare that right away, but I find you've got a bit of time. So you can see there's a big difference in color between the hardness one and the soft water one. So the soft water one, as you can see, it lines up with the chart 0 grains per gallon or 0 parts per million. And the hardness one, you can see it's pretty close to this 15 over here. It's definitely higher than the 7. So 15 is 250 parts per million. So you can see a big difference between the two. So the most accurate way and the way to know exactly how hard your water is to mail us a sample. We offer free water testing here at the store, so just mail us a sample and we'll use our test kit. This is just one of the test kits that we have, and we'll tell you not only how hard the water is, but we'll also tell you how much iron there is, what the mineral content is in parts per million. We'll check the pH, and if there's color in the water, we can test for tannins too. How hard is too hard? Well, I'll put a link to the cards and in the description down below. That'll take you right to a YouTube video of mine that explains what level of hardness you should actually be looking for and what level of hardness you definitely want to avoid. Check it out. A quick water fact. Did you know that if you have a tankless hot water heater and you're...
Okay, so through this video, one simple way to test whether it's a soft or hard water, you just need to shake, put in a little bit salt, and then you shake the water. Okay, so yeah. So we have 2 types of hardness. Okay, I'll show you all the information. So we have temporary hardness and permanent hardness. So both category have calcium and magnesium. This one also have calcium and magnesium. If your calcium magnesium fall under, if you have calcium magnesium bicarbonates, it fall under temporary hardness. If your water contain calcium magnesium sulfate or chlorides, then it fall under permanent hardness. Okay, so what does CaCO3 calcium carbonate can do? It will cause your water become alkaline. Okay, CaCO3 calcium carbonate, it means limestone. However, it's very rare in water supply, just take note. When you're near to the mountain area that have a limestone, then you have this element in the natural water, right? CaCO3, CaCO3 cause alkaline in the water. And then I've shown you before in our lecture that how calcium carbonate become bicarbonate. There's a process there. So when you have calcium bicarbonate with this equation, so this calcium bicarbonate actually it form a scale. This is the thing that you can find inside the water pipe with maybe a little bit of white color powder, right? So this is the products that you will see in a pipe. Okay. While for permanent hardness, for example, calcium sulfate, CaSO4, CaSO4, this one you can find in the boiler. Okay. Calcium sulfate is like you know, plaster of Paris. Plaster of Paris is like those having a bone crack in an accident, and then they wipe the hand with the white plaster, right? The paste with the white color one. So that is a plaster of Paris. Okay, so that one, if this component, calcium sulfate powder, appeared in the water, then it will form scale inside the boiler. Then another one is calcium chloride. Calcium chloride, CaCl. This one, this salt, as long as you see chloride, no matter what is in front of the chloride, you see chloride, it will create acidic solution. Okay. Okay. No matter what is in front, but I give you an example. These slides give you calcium chloride, right? So if you have a chloride component in your water, you have a high chances to having a low pH, mean you will be near to the acidic properties. Okay, so under hardness, you have two types of hardness, temporary and permanent. Right? So this is the process if you're interested in. So as you can see here, CaCl2 chloride plus water, you will get something plus HCl. You know hydrochloric acid, right? So HCl is something that is acid. This is the products after the chemical mix together. All right. So this equation we're going to tell you why when your water have something chloride, you're going to get acidic solution. Okay. And just add-on information. When you talk about pH, right? Again, pH is a measurement of H positive concentration in the solution. So if you have more H positive in the solution, means H positive charge of this one, for example, if you have a loss of H positive in the solution, then when you measure the pH will be very, very low. Okay, it will at the low side of the pH, then it will give you acidic reading. So if you have lots of OH negative, if you have OH negative, then your pH will going to increase. It will become more alkaline. So you are playing around with H positive charge and OH negative charge. If you have more H positive, means your water will get more acidic. If you get OH negative more, then you get more alkalic solution. Okay, so take note on that. That is a basic of corrosion environment. So if you have this basic, then you're able to explain why the corrosion can be happen and why the environment can increase the rate of corrosion there. Okay. Now we talk about pH of water. So water normally they will have a range of 4.5 to 8.5. Okay, so normally you have this range. It won't fall below 4. It will not go above 9. Okay, very, very rare to go outside this range. Huh? Okay, now I'm going to introduce one chemical member called copper. Okay, so copper is something, okay, this member here, copper, is very interested to change your pH value of your water. All right. So if you use a copper pipe, very high chances you will have pitting corrosion in there. If you do not do any maintenance, if you do not do any protection on the surface of the copper pipe, then you will have pitting happening on the metals itself. Okay. Okay, we have done for the natural water. Next, we look at seawater. Okay, so natural water we have done already. Okay, next we look at seawater. Now, why seawater is under our module here? It is because when you talk about corrosion, with one area of application of water is using seawater. All right, so seawater most probably the application will be on the factory and even in a ship or in the engine, marine engine that they use to cool down the engine, and they even use to generate steam for the operation. Okay, so this table give you the normal concentration of ion and molecules in the clean seawater. Okay, so this table show you all the popular members of seawater. So if you pick a drop of clean seawater, clean seawater means not polluted, there is no impurity, right? So so when you test the clean seawater inside lab, okay, so you control the clean seawater at 35% salinity and density of so and so, temperature so and so, because if you change the temperature, the concentration will change. So all this, when you study chemicals, temperature you fix, density, salinity you fix. Then you have all these members. So you have Na plus, Br negative, and so on. So this one you can see. Okay. Again, I want to introduce you this member one more time, Cl. So in seawater, we have a Cl negative. Just now we mentioned when we study about natural water, we talk about chlorine, right? So chlorine is something that will generate acidic solution. So this is a very dangerous member. So also very popular when it comes to corrosion. So recognize this member, Cl. All right. So you have a Cl negative charge in the seawater. And in fact, if you look at the table here, Cl negative is the main population inside the seawater. Clean seawater is a main population inside there. We use, for chemistry, we use concentration. Okay, concentration, millimole and kilogram. Okay, so just take note. On seawater, there are two main members on this table. You can see Cl negative and Na plus. Okay, but Cl negative is more contribution towards corrosion. Okay. So why seawater so important? There are some properties why we use seawater in our application, in engineering application. These are all the properties. Okay, so you can read from my slides. I just picked a few. So because seawater, you know that our Earth contains a big portion of seawater. So the concentration ratio actually can consider quite constant throughout the globe. Right? Then very high salt concentration, which is sodium chloride. And again, you see the member of Cl here. All right, chloride is inside the seawater. And you know that if you have Na, you have a positive charge, negative charge, then electricity can be happen, right? And then, yeah, this one linked with the first point, because the seawater is shared in a very big area of the Earth. So you have a very constant pH level, no matter where you go. I want to highlight this one. Solubility for gases. Solubility for gases, it means that because seawater is having water properties, so it's able to mix well with gases, right? So seawater, you know, that have wave. So when you have wave, you go into the surface and then it will capture some of the element or some of the gases in the atmosphere, and then it collapses down to the ground, to the water level again, and then there is a mixing of solution happen at the surface there. Okay, so the next, the rest you can read over here. So one of the scientific parameter we use to describe seawater is salinity. Okay, given by this equation. Okay, so it's a very lengthy equation, but it's a standard equation used throughout the world when you talk about salinity, or when you refer to a table that give you water quality chart. All right. So when they mention salinity, they are using this formula. So this formula, as you can see, they have some constant value there, and there's a K value there. Okay. So K value is conductivity properties of the seawater. Okay. So when you think of seawater, when you explain about seawater, think of the flow of electricity, and think of, because of the flow of electricity, we use the wording of conductivity. Okay, so salinity linked with conductivity, and you're having one equation for that salinity. All right. And this formula works for standard temperature and standard atmosphere. Okay, so if you change your temperature, you change your pressure, the value, the constant in front of K and the exponential above the K will change. All right. So what is important on this slide is that you take corrosion engineering before, so you should able to communicate well when corrosion engineer talk about salinity. You should able to recall, oh, there is a formula for salinity that link with the conductivity. Okay. Okay, the rest you can read over here. We as a mechanical engineer, at least minimum, you know how to measure salinity, right? At least you can communicate well with the water expert, right? So I show you on one video, right, how to measure.
Hey guys, Josh here again, bringing you a video on how to measure your salinity. So let's get right to it. We currently have two devices to measure salinity. First up, the hydrometer. The hydrometer is a plastic device with a swing arm in it. When filled, the swing arm will rise and point to the current salinity of the water sample. Let's see how it's done. First, we submerge the hydrometer. Once filled, we place the hydrometer on a flat surface. Then we get our reading. Pro tip, ensure that you rinse out your hydrometer after every single use, because if you don't, salt residue or protein film can give you a false reading. Next up, we have the refractometer. The refractometer is a precision instrument that is used to measure salinity. A refractometer works by measuring how much light bends as it passes through the water sample. As the salinity in the water changes, so does the angle of refraction. So let's see how it's done. First, we get a sample of our water, place it on the prism, close the lid, and look through it like a telescope. That's it. Pro tip, when measuring salinity, point your refractometer to a good light source to get a clear reading. So now you know how to measure salinity. But what are the pros and cons of each device? Hydrometer pros. Hydrometers are cheap, easy, and provide a fast reading. Cons. Over time, they lack accuracy. Your hands will get wet. What are the refractometer pros? Refractometers are accurate, able to be calibrated, and your hands will not get wet. Cons? The price. I only use refractometers. They're a little bit more expensive, but they do pay for themselves in the long run, with the capabilities of being able to be recalibrated and providing you an accurate reading every single time. So there you have it. I hope you liked this video, and if you did, hit the like button, share it with a friend, don't forget to subscribe.
Okay, now through this video, you know that there's two ways of measuring salinity. And where can you find all these instruments in your daily life? If you go in and visit aquarium, or just a nearby those store that sell the decorative fishes, right? The aquarium store just around you. Those serious business owner, they will have this refractometer, right? If you have one around you, they can go and ask the help from the boss to maybe just to show you what is a refractometer, right? Or if you go and visit aquarium at the national level, then maybe you can walk by and talk to the aquarium staff to show you how to use the refractometer, right? Okay, next will be about the pH of the seawater. So pH of the seawater will be more than 8, which is, as you can see, the value is more than 8, means it will be alkaline solution. All right, you're near to alkaline solution. So again, when you talk about pH, you talk about two charges, H positive and OH negative. So if you have pH more than 8, then you have the OH negative element higher than the H plus element. Okay, so if you have a pH higher than 8, meaning you are competing between H positive and OH negative. So when you have a higher pH value, means your OH negative charge concentration is higher than the H positive. Okay, have that in mind. Then you should able to answer the question in the test or final exam. All right. So yeah. So this is a overview chart for water. What happened in the water, seawater, and how acidification can happen in the seawater. All right. So you after that, after you download the PowerPoint slides later, you can see all these small wording here. All right. So what is important for this slide is that I want you to look for the flow of the chemical process. What happened at the surface? Okay, what happened at the surface? What happened at the bottom? Okay, so surface, bottom, we call it subsea level. Subsea level. So subsea means below water, right? So at the surface, there's something happen over here. And then at the bottom or subsea, you will see something other happen because of the marine life over here. So you know that marine life, most of them mix of when they die, they become something that contain calcium. All right, so calcium mixed with the chlorine, chloride, Cl negative, and so on. So they will become a calcium carbonate and become calcium bicarbonate. All right, so then you have you have the permanent and the temporary. You have then you'll see you have the hardness of the seawater, right? So you change the hardness of the seawater. Just now I showed you is the natural water, but the same concept apply to seawater. So this is a bigger picture. So you can see what happened in the air. So CO2 mixed with the water, and then the water capture the CO2, it becomes something else. Then inside there, you break away the charges, and you see there's a charges of H positive here. And I just explain what is the pH value mean, right? You're playing around with the H positive and OH negative. So if you go deeper, you mix with more all the marine dead body, then it becomes something else, and so on, okay? Next, we talk about precipitation of inorganic compound from seawater, something called calcareous flume in seawater. What is calcareous flume? Later, I'll show you one microscopic image. So this flume, what does it do? Flume is a layer above a object surface. So it form a flume. If you put element inside seawater for a period of time, then it will form a flume above the surface. So what does this flumes will do? So this flume, it will enhance the oxygen concentration polarization. It will reduce the current density. Okay, it will reduce the current density. Now we have covered this one in chapter 2 about current density. So this flume will reduce the current density. Okay, so this process will happen on the aerated water. What I mean by aerated? Aerated means you mix the water with oxygen, right? So aerated water means you mix the water, you mix H2O with oxygen. So because some of the time when you go to shopping mall, mineral water, sometimes they also put aerated water in some of the label on the mineral water, okay? Or they call it O2 water, oxygen water. So the chemical reaction is happen like this: oxygen plus water plus 4 negative charges, you become OH negative. So this equation tell you about the pH already, okay? So because you're seeing OH negative charge, right? So another process that might be happen, okay, might be happen. So a reversible process for the hydrogen can be happen. So this is the principal reduction reaction happen in the seawater. However, during the reaction happen, there will be another sub reaction happen, which is the water will mix with the, meaning without the oxygen, the water will mix with the charges, negative charge, it become hydrogen and creating OH negative also. So you can see that these two process creating OH negative, okay? So OH negative, scientific name for them is hydroxyl ion, okay? Hydroxyl ion. So by looking at OH negative charges created in this process, in the reduction reaction, in the aerated water, you're going to change your pH value, okay? So these are the two processes happen in the either it's aerated or without oxygen. When you mix water with charges, you're going to create hydrogens and hydroxyl ion. Okay, so what are the difference between the first one and second one? First one equation is for aerated water, where you mix oxygen with water, you will get this equation. Even in the process without oxygen, you only mix water, you add a little bit of charges, you get hydroxyl ion also. Okay, so this is the calcareous flume if you look under microscope. Okay, so it will be like something, if you go to the beach, and you try to observe the side of the ship, sometimes they have this very small, like a shell shape just beside the body of the ship, right? So this is called calcareous flume, right? So this is under microscope lah, then you will see. So by having these two elements, OH negative or OH negative hydroxyl ion, it's going to increase pH. It's going to increase pH. So in this module, try to be sensitive on the wording of increase pH or decreasing pH. So when we talk about increasing pH, means it become more alkaline, or you are actually producing more OH negative charge in the solution. Okay, when you talk about decreasing pH, meaning you talk about you increasing H positive or you decreasing OH concentration. Clear? Okay, let me ask question and also check attendance. Sivandra is not here. Mohit, are you there?
Yes, sir.
Okay. Mohit, when you have more OH negative in your solution, what is the pH value that you expect to get? When you have a very high concentration of OH in your solution, what pH value that you expected to get?
More alkaline.
Why more alkaline? What is the meaning of pH value? Can you explain pH value?
The pH value is like to measure the how acidic or how alkaline the substance is.
Okay, so what actually the chemical element that we're looking at when we talk about pH?
Hydrogen.
Hydrogen and
OH negative.
it's not hydrogen, but it's the H what?
H
Hydrogen
positive.
is a H2, right?
Yeah,
So
H positive.
H positive and OH negative.
negative.
So just now the question I asked you, if we have a lots of OH negative in the solution, so what will be the pH value will be? You will become more acidic or alkalic if you have more OH.
If I'm not mistaken, is alkaline, sir.
Okay, so you become more alkaline. You are increasing the pH or you're reducing the pH if you have more
increasing the pH.
Okay, correct. Okay, good, Mohit. Excellent. So again, these are the way we play around with the wording. So either you increase, if you have pH value, actually you're playing with H positive charge and also OH negative. All right. So just take care of the wording that you use. It's a H positive ion charge. It's not hydrogen. Hydrogen is H2 molecule. All right. So we are playing with charges when we talk about pH. Okay. As you can see, the pH in the seawater, just now in the ocean chart that I give you just now, you can see that actually the acidic in the ocean chart just now. Let me bring you back to the big photo. So this table, it just shows you the contribution of carbon dioxide. Okay, the acidification process normally linked with CO2. Okay, so chemical reaction is given by this equation. So when we have water mixed with carbon dioxide, it becomes this component. And this component, H2CO3, it can break into charges. H2CO3, it can break into two charges, H positive and HCO3 negative. And this one, HCO3 negative, it can further break into H positive and CO3 2 negative. So you can see from the first process into the second and third process, do you see something linked with the pH value? The H positive is there. After you mix carbon dioxide with water, you get this one, H2CO3, and automatically in the solution, because of the covalence and chemical properties, H2CO3, it will like to have a tendency to break into charges or ion. You get H positive, and another products of HCO3 negative also have a tendency to break itself to contribute another H positive charge in the solution. So when you have H plus in the solution, you're going to get more acidic in the water. Okay, now before we move forward, from these slides, CO2 plus water, you get H positive and aerated water. When you mix water with oxygen plus negative charges, you get OH negative, and OH negative give you alkali. Basically, you can explain about prevention of corrosion already based on this formula and this formula. One, you use oxygen. One, you use carbon dioxide. If you use oxygen plus a little bit of charges, you get hydroxyl charge or OH negative, where you're creating a more alkali solution. If you mix carbon dioxide into the water, you get more H positive, means you get more acidic solution. So by having these two processes, you can play around chemically to balance the charge in the solution. If the solution too acidic, you pump oxygen into the water, you're creating more OH negative, it will change the acidic water into a towards more neutral direction. Okay, but if you want to put the water, if the water too alkalic or pH level too high, what do? You pump in carbon dioxide into the water to produce more H positive. It will bring down the pH level drop to more neutral level. Okay, so you play around these two elements, carbon dioxide and oxygen, is something is important in corrosion protection or prevention of corrosion. This is another one. What happens if you add hydroxyl into this process that I mentioned just now? So when you add CO, carbon dioxide, and the hydroxyl, it becomes HCO negative. And then another OH negative plus these products, it become water, and you get CO32 negative. And CO2 negative plus calcium, you will get calcium carbonate products. Where is this calcium come from? In seawater. Calcium, this one you think of all the coral, all the marine life that have scalp, no? But most of the coral, they are consist of they have the calcium element there. All right. So when the products of OH32 negative combined with the calcium charges, it will become calcium carbonate. And just now, we talked about calcium carbonate just now. Okay, so they will tell you the hardness of the water. All right, calcium carbonate is a precipitation, or this one is, you can see as a powder form, right? It will become powder form. So this one also, I showed you one video where the EMT officer, it mix calcium and magnesium together, then you get precipitation. So this is also one of the process where you get precipitation. Okay, so it will tell you in a normal case when you have a carbon dioxide and how you get calcium carbonate in the water, in the seawater, especially at the lower level of the subsea, when you have all the corals and dead corals that that change into calcium element. So this calcium element will mix with this one and it will form precipitation, right? And sometimes this precipitation was, sometimes all these charges was sucked inside the marine engine to cool down the mechanism. So this one, when you have two charges in the water and suck into the pipe inside the marine ship or all this, so all this will stick to the walls of the pipe. So, and then when engine is very hot and you increase the temperature, and corrosion is going to take place. So that's why you see the pitting will happen and so on. Later we look into pitting corrosion, but today we look at seawater. Okay, so I hope through these a few slides, you can see the reason behind why corrosion can happen in the seawater environment. Okay. Next, we talk about corrosion resistant. Corrosion resistant. Let me see. Okay. Let's stop for a short break. Okay. I will stop the recording.